At first, it sounds like a ghost story. Imagine sitting in a high-level briefing in Berlin, 1943. You are surrounded by the most advanced radar technology and anti-aircraft batteries in the world. You're told that your steel fortress is impenetrable. Then, without a single blip on your screen, a bomb drops through your roof. It sounds like a ghost story, but for the Luftwaffe, it was a daily humiliation. They called it the Schreckgespenst, the bogeyman. To the world, a wooden airplane was a relic of the Great War, a fragile toy. But the reality was a physics-defying masterpiece of Canadian birch and Ecuadorian balsa that outran the fastest jets of the era. Tonight, we're looking at why the U.S. Army Air Forces eventually ditched their metal scouts to adopt this flying furniture and how it became the most successful reconnaissance bird in the history of the war. Think back to the late 1930s. If you were looking at the cutting edge of aviation, you saw the gleam of polished aluminum and the industrial strength of steel. The world was convinced that the next great war would be won by heavy metal, massive armored fortresses bristling with machine guns. It was an era where weight equaled power, and wood was something you used for biplanes and memories of a bygone age. But while the rest of the world was doubling down on rivets and heavy plating, a man named Geoffrey de Havilland was looking at a tree and seeing the future of speed. You see, the common belief was that a bomber needed to be a flying tank to survive. The contrarian reality, if you were fast enough, you didn't need a single gun to defend yourself. You just needed to be a ghost that the enemy couldn't catch. Many of us remember the sturdy, reliable feeling of a well-made piece of furniture, the weight of birch or the lightness of balsa. It's hard to imagine those materials holding together at 400 miles per hour, but that's exactly where the genius of the wooden wonder began. The British Air Ministry initially laughed at the idea. They called it Freeman's Folly, named for the one air marshal who dared to back the project. The Germans were even more dismissive. To the Luftwaffe, the idea of a wooden bomber was a joke, a wooden toy that would surely disintegrate under the pressure of modern combat or catch fire at the first hint of a tracer round. However, wood possessed a secret weapon that steel couldn't match, a superior strength-to-weight ratio when used in a monocoque design. De Havilland didn't just build a wooden plane, he pioneered what we'd call composite technology today. Imagine a sandwich where the bread is thin sheets of Canadian birch and the filling is soft Ecuadorian balsa. By gluing these together over concrete molds, they created a fuselage that was incredibly light, remarkably stiff, and crucially as smooth as glass. Unlike metal planes of the time, which were covered in thousands of drag-inducing rivets and overlapping seams, the Mosquito skin was seamless. Therefore, it didn't just fly, it sliced through the air with a level of aerodynamic cleanliness that left even the legendary Spitfire in its wake. It was a 20-mile-per-hour advantage born entirely from the carpentry shop. But the choice of wood wasn't just about speed, it was a masterstroke of wartime logistics. While the world's supply of aluminum was being choked off by the demands of mass production, wood was plentiful. More importantly, the labor was available. Instead of waiting for specialized metalworkers, de Havilland tapped into a different kind of veteran, the master carpenters, cabinet makers, and piano tuners of High Wycombe. They weren't building flying furniture out of desperation. They were using a non-strategic material to build the fastest aircraft in the sky. By the time the Germans realized that this wooden toy could outrun their best Messerschmitts while carrying a 4,000-pound bomb load, the laughter had turned into a desperate green-eyed envy. As Hermann Goering himself would later admit, the British had turned sawdust and glue into a nightmare that his Luftwaffe simply couldn't catch. In the high-stakes poker game of the 1930s military procurement, the British Air Ministry was betting the house on heavy metal. To the brass in London, the future of aerial warfare was written in the thick corrugated steel of the Vickers Wellington or the heavy-duty rivets of the short Sterling. They wanted battle wagons, mammoth machines that could absorb 1,000 rounds of machine gun fire and limp home on a prayer. Therefore, when Sir Geoffrey de Havilland walked into the room with a blueprint for an unarmed wooden bomber, the reaction wasn't just skepticism, it was borderline insult. The establishment viewed the concept of an unarmed bomber as a tactical heresy. At the time, the prevailing doctrine was the bomber will always get through, but only if it was protected by a fortress of turrets. De Havilland's proposal discarded the turrets, the gunners, and the ammo belts entirely. His argument was elegant. Weight is the enemy of speed, and speed is the ultimate defense. But to a ministry obsessed with defensive firepower, a plane without a gun was like a soldier going over the top without a rifle. They mockingly dubbed the project Freeman's Folly. Sir Wilfrid Freeman, the Air Member for Development and Production, was the only man in the room who saw the genius in the madness. He understood a truth that the others were too rigid to see. Britain was facing a critical shortage of aluminum. If a war broke out, the metal-only mindset would create a bottleneck that could lose the war before it truly began.
But the ministry wasn't moved by logic. They were moved by tradition. They looked at the de Havilland Company and saw a firm that built civil racers and light moths, the sports cars of the sky. They didn't think the piano makers from Hatfield were capable of building a real war machine. The project was officially canceled not once, but twice. It was removed from the official production programs after the fall of France in 1940. The logic was cold. Britain was under siege, and every ounce of energy had to go toward building Spitfires and Hurricanes. There was no time for experimental wooden toys. But here is where the story takes a turn that many of us who have lived through lean times can appreciate. De Havilland didn't stop. He moved the design team to a secluded Tudor manor called Salisbury Hall. It was a clandestine operation, hidden away from the prying eyes of the very ministry that was supposed to be funding them. They worked in a small, cramped hangar disguised as a common barn, literally building the future of aviation in the shadow of a medieval moat. The but that changed history came in the aftermath of Dunkirk. Suddenly, the flying furniture didn't look like a folly anymore. It looked like a lifeline. Britain's aluminum foundries were prime targets for the Luftwaffe, but the furniture factories, the piano workshops, those were scattered across the countryside, invisible and untouched. Sir Wilfrid Freeman pushed one last time. He essentially told the ministry, if we can't build them out of metal, let us build them out of trees. He knew that the Mosquito wasn't just a plane, it was a way to mobilize an entire workforce of civilian craftsmen. Men who knew how to work a lathe and a chisel, but had never seen a rivet gun in their lives. By November 1940, the prototype W4050 was ready. The Air Ministry sent their top test pilots to Hatfield, expecting to see a fragile, sluggish wooden crate. Instead, they watched as the yellow-painted prototype took to the sky and proceeded to outrun every fighter in the RAF inventory. It wasn't just faster than the bombers, it was faster than the Spitfire Mark II. The critics were silenced by the sheer physics of the machine. The flying furniture had reached 392 miles per hour. Therefore, the ministry had no choice but to admit their error. The very features they had ridiculed, the lack of guns and the wooden skin, were the reasons the Mosquito could fly higher and faster than anything the Germans had on the drawing board. This wasn't just a win for de Havilland, it was a victory for the contrarian spirit. It reminds us that often the experts are the ones most blinded by the status quo. They were looking for a better version of yesterday's plane, while de Havilland was building the first version of tomorrow's. But as the Mosquito entered production, a new problem emerged. It was one thing to build a masterpiece in a barn. It was quite another to mass-produce a high-performance aircraft using nothing but glue and wood in the damp, unpredictable climate of the British Isles. The legend was born, but the battle to keep it in the air was only just beginning. To understand why the Mosquito was a marvel of physics, we have to look past the wooden label. In the 1940s, wood was seen as a primitive material, something for crates and campfires. But de Havilland wasn't just using wood, he was building the world's first true composite aircraft. If you've ever handled a high-end fly fishing rod or seen the carbon fiber on a modern racing car, you're looking at the direct spiritual descendant of the Mosquito's sandwich construction. The primary challenge of high-speed flight is a phenomenon called parasitic drag. On a metal aircraft like the B-17 or the Lancaster, the skin is held on by tens of thousands of mushroom head rivets. Each one of those rivets creates a tiny pocket of turbulence. It's like trying to swim through a pool wearing a suit made of sandpaper. But the Mosquito was different. Its fuselage wasn't built like a traditional plane. It was molded in two vertical halves, much like a walnut shell. The physics of speed here relied on a three-layer sandwich, an inner skin of three-ply Canadian birch, a core of light Ecuadorian balsa wood, and an outer skin of birch. This was then glued together using casein or later beetle synthetic resins.
The result was a structure that was incredibly thick and stiff, yet lighter than a metal skin of the same strength. Because the wood was thick, it didn't need the internal heavy ribs and stringers that metal planes required. This left the inside of the Mosquito hollow and spacious for equipment, while the outside remained as smooth as a polished billiard ball. When you ran your hand over the wing of a Mosquito, you didn't feel a single bump or seam. Therefore, the air didn't trip over the aircraft, it flowed around it with laminar efficiency. Many of us who have worked in a wood shop know that wood is strong under tension, but it can be brittle. However, by using balsa as the filling, de Havilland solved a massive engineering hurdle. Balsa is mostly air. It has almost no structural strength on its own. But when sandwiched between the rigid birch layers, it acts as a spacer that keeps the outer skins from buckling. Think of it like an I-beam. The top and bottom flanges of the beam do the heavy lifting, while the vertical web just keeps them apart. In the Mosquito, the birch was the flange, and the balsa was the web. This allowed the aircraft to withstand 7G maneuvers, forces that would have caused the thin aluminum skins of a measurement to oil can or ripple, creating even more drag at the exact moment the pilot needed speed. But speed isn't just about aerodynamics, it's about power to weight. The Mosquito was powered by two Rolls-Royce Merlin engines, the same heart that beat inside the Spitfire and the Mustang. But while the Spitfire had one Merlin to move about 7,000 pounds, the Mosquito had two Merlins to move a streamlined wooden shell that weighed significantly less than its metal counterparts. The German High Command, specifically the head of the Luftwaffe, Hermann Göring, was obsessed with the superiority of German metal. When he first heard reports of an unarmed British plane outrunning his fighters, he simply didn't believe it. He famously fumed, "I am going to build a club of my own. It makes me furious when I see the Mosquito. I turn green and yellow with envy." The but that haunted the Luftwaffe was the altitude. Because the Mosquito was so light, it could climb to 30,000 feet in a heartbeat. At that altitude, the air is thin, and the Merlin engines, equipped with two-stage superchargers, were in their element. German interceptors, laden with heavy cannons and armor plating, struggled to breathe in that thin air. They would chase the wooden wonder, only to find that as they reached its altitude, the Mosquito would simply open its throttles and pull away. It was a humiliating spectacle for the Germans. Their most advanced jet prototypes, like the Me-262, were eventually the only things that could consistently catch a Mosquito. But those jets were plagued by engine failures and short flight times.
The most common criticism of the Mosquito was that it would be a flying tinderbox. It's a logical assumption. Wood burns, metal doesn't. But the reality of physics told a different story. In combat, when a 20mm cannon shell hits a thin aluminum wing, it creates a flowering effect, where the metal peels back and creates massive drag, often shredding the entire structure. When a shell hit the thick plywood of a Mosquito, it often made a clean hole. The wood didn't petal or shatter. Furthermore, the beetle resins used to bomb the wood were surprisingly resistant to heat. There are numerous accounts of Mosquitoes returning to base with massive sections of their wings charred by fire or shredded by flak, yet the sandwich remained structurally sound. A metal plane with a melted spar would have folded. The wooden wing, with its distributed load-bearing skin, kept flying. Perhaps the most fascinating physics of speed wasn't about the air, but about the waves, specifically radar waves. We'll dive deeper into this in the next chapter, but it's important to note here, wood does not reflect radar the way metal does. The Mosquito wasn't just fast, it was functionally blurred on the enemy's monitors. While a formation of metal B-17s looked like a giant glowing target on a German Freya radar screen, a single Mosquito looked like a bird or a glitch. By the time the German controllers realized what they were looking at, the Mosquito had already dropped its payload and was halfway back to the English Channel. It was the ultimate expression of de Havilland's philosophy. You don't need to be tough if you're invisible, and you don't need a gun if you're already gone. This was the genius of the wooden wonder. It turned a primitive material into a high-tech solution that out-engineered the finest metalwork of the Third Reich. But as the war progressed, this speed wouldn't just be used for bombing, it would be used for the most dangerous job in the sky, looking the enemy right in the eye without a single gun to blink back. In the 1940s, the concept of stealth didn't exist in the military lexicon. Radar was the terrifying new eye of the storm, a revolutionary technology that could peer through the darkest night and the thickest fog to find an approaching enemy. The Germans were masters of this craft, erecting a formidable Kammhuber line of radar stations from the tip of Norway to the coast of France. They believed that if you were in the sky, you were seen. But then came the Mosquito, and for the first time, the eye of the Reich began to blink.
To understand why the German radar operators were pulling their hair out, we have to look at the physics of radio waves. Radar works on a simple principle. A transmitter sends out a pulse of electromagnetic energy, it hits an object, and it bounces back. Metal is a fantastic conductor. It reflects those waves with the clarity of a mirror. When a formation of aluminum B-17s or Lancasters crossed the channel, they showed up on German Freya and Würzburg radar screens as massive, undeniable blips. But wood? Wood is an insulator. Instead of acting like a mirror, the plywood skin of the Mosquito acted more like a sponge. A significant portion of the radar energy didn't bounce back. It simply passed through the wooden skin or was absorbed by the organic fibers and the resins holding them together. Therefore, on a radar screen, a Mosquito didn't look like a lethal twin-engine bomber. It looked like a smudge, a ghost. Often, it didn't look like anything at all until it was far too close to intercept. This wasn't a feature de Havilland had specifically designed for. It was a happy accident of the material choice, but it changed the geometry of the air war. The Germans relied on a system called ground-controlled interception. A radar operator on the ground would track the British bombers and vector a night fighter onto their tail. But because the Mosquito's radar cross-section, RCS, was so much smaller than its metal counterparts, the ground controllers struggled to give their pilots accurate coordinates. Imagine trying to catch a fly in a dimly lit room using a flashlight that only works half the time.
By the time the German Nachtjagd night fighter pilots, like those flying the Messerschmitt Bf-110, received their orders, the Mosquito had usually already used its superior speed to exit the radar's effective tracking zone. But the but in this equation was the internal components. While the skin was wood, the engines were massive blocks of steel and aluminum. These did reflect radar. However, because these metal components were shielded behind thick wooden wings and a plywood fuselage, the return signal was fragmented. It lacked the cohesive signature of a metal fuselage, making it incredibly difficult for German automated gun-laying radar to lock on. This invisibility led to the creation of the light night striking force. While the heavy Lancasters were doing the bruising work, the Mosquitoes were doing the haunting. They would fly solo or in small pairs over Berlin, night after night. For the elderly men and families on the ground in Germany, the Mosquito became a psychological terror. You wouldn't hear the heavy drone of 1,000 bombers. You'd hear the high-pitched scream of 2 Merlins, a sudden explosion, and then silence. The German sirens would often go off after the bombs had already fallen because the radar hadn't picked them up in time. The Luftwaffe tried to counter this by creating wilde Sau, wild boar tactics, where single-seat fighters would look for the Mosquitoes by the light of the fires below, rather than relying on radar. But even then, the Plywood Ghost had one more trick up its sleeve. Because it was so light and had such a clean wing, it could outturn almost any German night fighter. As the war progressed, the British began to use the Mosquito as a pathfinder. They would fly ahead of the main bomber stream, using their stealth-like properties to slip past the outer radar pickets and drop colored flares, Christmas trees, to mark the target. The Germans eventually developed the Liechtenstein airborne radar for their night fighters to hunt mosquitoes more effectively. But again, the physics of wood intervened. The wooden nose of the Mosquito allowed the British to install their own massive radar dishes, like the AI Mark 8, without the metal interference that plagued other aircraft. This turned the prey into the predator. The Mosquito became a night fighter hunter, using its own radar to find the Germans who were trying to find them. It was a deadly game of cat and mouse played in the dark, but the cat was made of Canadian birch and Ecuadorian balsa. The German pilots, who had once ridiculed the wooden toy, now spoke of it with a hushed, begrudging respect. They called it the Schreckgespenst, the bogeyman. By the time the U.S. Army Air Forces looked across the Atlantic at the success of the Mosquito, they didn't see a furniture project. They saw the most sophisticated reconnaissance platform on the planet. Therefore, the Americans, who usually insisted on building everything bigger and louder, made a rare decision. They decided they needed the wooden wonder for themselves. When the first de Havilland Mosquitoes began arriving on American shores, the reception from the USAAF was, to put it mildly, lukewarm. We have to remember the American industrial mindset of the early 1940s. This was the arsenal of democracy. We were a nation of steel mills and massive assembly lines. Our philosophy was built on the heavy principle, heavy bombers like the B-17 Flying Fortress and heavy fighters like the P-47 Thunderbolt. To the generals in Washington, a plane made of wood and glue felt like a step backwards, a desperate improvisation rather than a serious weapon of war. The initial American skepticism wasn't just about the material, it was about the mission. General Hap Arnold and his staff were committed to the doctrine of daylight precision bombing. Their strategy relied on massive formations of heavily armed aircraft that could fight their way to a target. When the British offered the Mosquito, the Americans looked at the lack of defensive armament and shook their heads. They saw a suicide bird. But the but that changed the American perspective was the staggering loss rate of their own reconnaissance aircraft. Early in the war, the Americans were using converted P-39s, the F-4 and F-5, and even modified B-17s for photo reconnaissance. These planes were being chewed up by German flak and interceptors. They were either too slow to escape or too cumbersome to maneuver at high altitudes.
Therefore, the USAF faced a crisis of intelligence. They needed photos of the Reich to plan their 1,000-plane raids, but they couldn't keep their cameras in the air long enough to get them. It was only after seeing the Mosquito's performance over Berlin, flying with impunity while the Luftwaffe sat helplessly 5,000 feet below, that the American generals began to reconsider. In 1942, a deal was struck. The Americans would take delivery of British-built Mosquitoes designated in the U.S. system as the F-8. The transition was not without its cultural clashes. American pilots, used to the rugged metal cockpits of Boeing and Douglas aircraft, were suddenly sitting in a wooden bathtub. There's a great story about an American colonel who, upon seeing his first F-8, tried to test its durability by kicking the fuselage. He expected his boot to go through the wood. Instead, he nearly broke his toe on the incredibly dense birch and balsa composite. It was a grounding moment for American pride. The Americans quickly fell in love with what they called Photo Joe. The F-8 was stripped of all weight that wasn't strictly necessary. In place of bombs or guns, it carried an array of high-resolution K-17 and K-22 cameras. Because the wood was so easy to modify, the Americans could cut camera ports and install specialized heaters to prevent the lenses from frosting over at 35,000 feet, modifications that would have required weeks of structural engineering on a metal airframe. By 1943, the F-8 Mosquitoes of the 25th Bomb Group Reconnaissance were operating out of Watton, England. These men were the lone wolves of the American air war. While the big bomber boxes were slugging it out in the vertical meat grinder, the F-8 pilots were flying solo missions deep into the heart of Germany. The 15-second reward for the American High Command was the quality of the intelligence. Because the F-8 was so stable and fast, it could fly lower and faster over a target than any other recon bird. The photos they brought back were so sharp you could count the rivets on a U-boat in the Kiel shipyards or see the heat shimmering off the cooling towers at the Peenemünde rocket base. Many of us remember the pride of American manufacturing in that era, but the F-8 was a lesson of humility and adaptation. The Americans eventually tried to build their own version of the Mosquito, the Beechcraft XA-38 Grizzly, but they couldn't replicate the British magic with wood. The climate in the U.S. factories was too dry, and the American workers lacked the generational feel for timber that the British cabinet makers possessed. The success of the F-8 in Europe was so profound that the USAF eventually sent Mosquitoes to the Pacific Theater as well. There, the wooden wonder faced a new enemy, the tropical rot of the jungle. Many predicted the planes would literally melt in the humidity. But again, the genius of wood prevailed. By switching to more advanced synthetic glues, the beetle resins, the Mosquitoes held together even in the steaming heat of New Guinea. They became the eyes of the Pacific, mapping out Japanese island defenses that were invisible to traditional scouts. The American conversion was complete. The generals who once ridiculed the wood aircraft were now clamoring for more. They realized that in the chess match of global war, you don't always need the heaviest piece on the board. Sometimes you need the one that can move the fastest and see the furthest. The F-8 Photo Joe proved that even in the age of the machine, there was still a place for the craftsman's touch. If you've ever worked with a high-performance tool, you know that the secret to precision isn't just the sharpness of the blade, it's the stability of the hand holding it. In the world of 1944 aerial warfare, most bombers were like sledgehammers, effective but messy. They stayed at 25,000 feet and hoped their carpet of bombs would eventually find the target. But the Mosquito was a scalpel,
And because it was made of wood, it had a physical property that metal planes lacked. It was an incredible dampener of vibration. Therefore, while a metal B-26 Marauder would vibrate and chatter at high speeds, the Mosquito remained a rock-steady platform. This allowed pilots to do the unthinkable, dropping bombs into specific windows while flying at the speed of a modern commuter jet. How do you destroy a single building, like a Gestapo headquarters or a prison, without leveling the entire city block and killing the very civilians you're trying to liberate? The RAF's answer was the low-level sting. They trained Mosquito pilots to fly so low that they were literally clipping the tops of poplar trees and dodging church spears. They weren't using traditional bomb sights. They were looking through the windscreen and judging the distance by the size of the bricks on the wall. Take the Amiens prison raid, known as Operation Jericho. The goal was to blow holes in the prison walls to allow French resistance members, many of whom were scheduled for execution the next morning, to escape.
But there was a catch. If the pilots were off by just a few feet, they would collapse the cell blocks and kill everyone inside. Flying at 350 miles per hour, just yards above the snow-covered ground, the Mosquitoes hit the outer walls with such surgical precision that the prisoners were able to run for the woods before the German guards could even clear their eyes of the dust. To achieve this deadly accuracy, the Mosquito pilots perfected the art of skip bombing. Because the plane was so fast and sat so low to the ground, a bomb wouldn't just fall, it would skip across the surface of the water or the ground like a flat stone on a pond. Therefore, the Mosquito could thread the needle, skipping a 500-pound bomb right into the front door of a reinforced bunker. This was the ultimate nightmare for the German occupation. You could be sitting in a commandeered office in The Hague, thinking you were safe behind concrete walls and anti-aircraft batteries, and a wooden wonder would appear at the end of the street, fly below the level of your roof, and put a bomb on your desk before you could reach for your pistol. Many of us remember the feeling of a job that requires absolute focus, one where a single slip-up means disaster. That was the Copenhagen shell house raid. The Gestapo had moved their headquarters into a building in the center of the city and, as a human shield, placed Allied prisoners in the attic. The Mosquitoes had to fly across the North Sea, navigate the narrow streets of Copenhagen, and hit the lower floors of the building while leaving the attic untouched. But the chaos of war intervened. One Mosquito hit a light pole and crashed into a nearby school. The following wave of pilots, seeing the smoke, mistakenly bombed the school. It was a tragic but in the Mosquito's legacy, a reminder that even with the most precise tool, the fog of war is never entirely lifted. Yet, despite the tragedy, the main mission succeeded. The Gestapo files were incinerated, and dozens of resistance leaders escaped the shell house in the confusion. The Germans tried to counter these low-level stings by lining the roofs of their cities with 20mm flak guns. They thought that if the British came in low, they'd be easy targets for a man with a machine gun. However, the physics of speed worked in the Mosquito's favor once again. At 400 miles per hour at 0 feet, the Mosquito was moving faster than a human could traverse a gun. By the time a German gunner heard the roar of the Merlins and turned his turret, the Mosquito was already a mile away, shielded by the next row of buildings. This was the deadly accuracy of the Mosquito's sting. It wasn't just that it could hit a target, it was that it could do so and survive to do it again the next day. While the heavy bomber groups were losing dozens of aircraft in a single afternoon, the Mosquito squadrons maintained the lowest loss rate of any aircraft in the entire Allied inventory. It was a validation of de Havilland's original, ridiculed vision. Speed is a more effective defense than 2 inches of steel plate. The wooden toy had become the most feared predator in the European theater, a ghost that could strike with the precision of a sniper's rifle from the seat of a 400-mile-per-hour hurricane.
As the dust of the Second World War began to settle in 1945, the Mosquito stood as a towering achievement of unconventional thinking. It had done everything the experts said was impossible. It had outrun the fastest fighters, survived the most brutal flak, and carried the heaviest payloads, all while being held together by the same materials used to build a grandfather clock. But as we look back from the vantage point of the 21st century, a question lingers for many of us who appreciate the craftsmanship of the past. If wood was so successful, why did we stop building masterpieces out of trees? The point is, for the decline of the wooden aircraft wasn't a failure of the material itself, but a radical shift in the environment of flight. In the late 1940s, the aviation world crossed the threshold into the jet age. Engines like the de Havilland Ghost and the Rolls-Royce Derwent were pushing aircraft toward the sound barrier. Therefore, the physics that made the Mosquito a wooden wonder became its primary limitation. As an aircraft approaches the speed of sound, it encounters compressibility, a massive increase in air pressure and heat. While the birch and balsa sandwich was incredibly stiff, it simply couldn't handle the localized skin friction and thermal loads of Mach 1 flight. Wood is a natural insulator, but it can char. Aluminum and newer titanium alloys could dissipate that heat and maintain their structural integrity under the violent buffeting of shock waves. Furthermore, the very thing that made the Mosquito a logistical miracle, the use of civilian woodworkers, became a liability in the era of mass-produced jets. Working with wood is an art form. It requires a feel for the grain, an understanding of moisture content, and a patience for the curing of glues. In the post-war world, the military-industrial complex demanded standardization. You can stamp out 1,000 identical aluminum wing ribs in a day. You cannot stamp out a piece of spruce. But the but in this story is that the Mosquito didn't truly die, it evolved. If you look at a modern Boeing 787 Dreamliner or a Lockheed Martin F-35, you aren't looking at a metal airplane. You are looking at an aircraft made of carbon fiber composites, layers of high-strength fibers bonded together by synthetic resins in a sandwich construction.
Sound familiar? It should. The de Havilland team pioneered the exact structural logic that defines the most advanced aircraft in the world today. They proved that a skin-bearing composite structure was lighter, smoother, and more efficient than a traditional metal frame. We didn't stop building with wood because the idea was bad. We simply traded the organic fibers of the forest for the carbon fibers of the laboratory. For the men who flew them, the American F-8 Photo Joe pilots and the British Pathfinders, the Mosquito remains a singular memory. There was a warmth to the aircraft that a metal plane could never replicate. A metal cockpit is cold, noisy, and rings like a bell when hit. A wooden cockpit was quieter, more insulated, and felt alive in a way that spoke to the pilots. Many of us who grew up in an era where things were built to last by hand can find a deep sense of respect for what de Havilland achieved. He took the oldest building material known to man and used it to defeat the most modern industrial tyranny the world had ever seen. He proved that genius isn't found in the most expensive materials, but in the most creative application of what you already have. The final echo of the Mosquito is a reminder that we should never be too quick to ridicule the old ways. Sometimes the most primitive solution is actually the most sophisticated. The Germans ridiculed the wooden toy until it was dropping bombs on their doorsteps. The Americans doubted the furniture plane until it became the only thing that could bring back the photos they needed to win the war. As the last airworthy Mosquitos roar at air shows today, the sound of those twin Merlins isn't just a tribute to an engine, it's a tribute to the cabinet makers, the piano tuners, and the visionary engineers who saw a forest and imagined a legend. History has a way of smoothing over the stories of the men who dared to think differently, but we shouldn't let the wooden wonder be one of them.
If you're the kind of person who still appreciates a tool built with a craftsman's touch, or if you remember a time when ingenuity mattered more than a massive budget, then you're in the right place. We're building a community here dedicated to preserving these unconventional chapters of our past. If you enjoyed this deep dive, consider hitting that subscribe button and joining us for the next one. But more importantly, I want to hear from you. Did you or your father ever work with these Merlins? Or perhaps you remember seeing the Photo Joe in action? Drop a comment below and let's keep this conversation going. It's through your stories that this history truly stays alive. We'll see you in the next one.